Hello, this is Dr. Mears. Today we are going to be looking at a finance problem. This is paper 1, example 10. This problem is about Pierre, and he invests 5,000 euros at a fixed deposit and pays a nominal annual interest rate of 4.5%, compounded monthly for 7 years. For A, we want to calculate the value of Pierre's investment at the end of the time, so we're looking for that value in the future. Give our answer to 2 correct decimal places. Please go to your formula booklet for page 3 and section 1.9. Again, page 3 in your formula booklet, section 1.9. Next to the formula that's labeled FV equals PV times this formula here, please write down paper 1, example 10, because that's where we're seeing it, paper 1, example 10. After you wrote that down, make sure that you have what each of these represents. So FV is the future value, PV is the present, N is the number of years, K is the number of compounding periods per year, and R is that annual interest rate. Okay, so we want to find the investment at the end, so we need a future value. So let's substitute our numbers in. So our future value is going to equal 5,000, that's our present value, times 1 plus, there's our rate R, times 100, divided by 100, times the compounding periods. Now it says compounded monthly, and monthly is 12 months in 1 year. So that's 12 here, and you have to put a 12 here, and that's times the number of years, which is 7. Using order of operations, multiply 12 times 7, and you get 84, and divide 4.5 times 1200. We add 1 to it, and we get 1.00375 raised to the 84. You can actually put this in the calculator just as is, making sure your parentheses are correct. We are going to be getting a future value of 6847.26. Now the decimal point, the reason why they wanted you to go to 2 decimal point is because it's money. So actually it's not, yeah, it's money in euros. So for an answer, you would put this down, but then you would put euros. Okay, let's see what they want us to do next. Here's this extra information I always say to star. Carla has 7,000 euros to invest in a fixed deposit, which is compounded annually. She aims to double her money after 10 years. Calculate the minimum annual interest rate needed for Carla to achieve her aim. So we go down here. Doubling your money. So if she wants to double her money, that means she wants 14,000. So remember, she started at 7.
Suarez, go up 2344, please. Mrs. Suarez, 2344, please.
Oh, there's Martinez. I'm not stopping the video. Sorry about the interruption. Okay, so she wants to double her money, so that's 14,000. This is what she started with. 1 plus, we don't know what our rate is, divided by 100, and then this is times 1 because that's our compounding period, just once. And up here, this is 1 times 10 because it's 10 years, so 1 times 10. By order of operations, let's just do 1 times 10, which is 10, so that's here. And then 7,000. Now, this is where your algebra skills are going to take flight. This 14,000 you have to divide by 7,000, and that's where I got my 2. 14 divided by 7 is 2. And because this is raised to the 10th power, to undo it, we have to raise it to the 1/10. So 10 and 1/10 cross out, so that gets rid of it. You may do this part in the calculator to raise to the 1/10. This is an exponent. Please make sure you have it in parentheses. You will get 1.072, which equals 1 plus r over 100. That means that we have to subtract 1 from both sides, and we get to up here. So minus 1 and minus 1 here. You get to 0.072. This was a minus 1. Equals r over 100, multiplied by r, and we're at 7.2, which I got 7.2%. So this was in euros, and this is in 7.2%. This has been, with a minimal interruption, a investment problem. If you need to rewind it, record it, not record it, I just did that. Please rewatch if needed. Hope this helped. Thank you.